Hello again. Welcome to topic 3.03, heat of phase change, as promised in the last video. In the last video, you saw that temperature remains constant during a phase change, and therefore we cannot use Q equals mc delta T to calculate the heat needed for phase change because there is no delta T. So what exactly do we do about that? Well, it's fairly simple. And also, a couple of other questions can be answered based on this. First, why do you sweat? And boy, do I sweat. And what are those lines on the back window of your car all about? Oh, yeah, I'll answer that one too. So here goes. This is the diagram you saw in the last video, showing that temperature can change while a phase is being heated up, but during a phase change, because temperature remains constant, we cannot have a temperature change, and therefore we can't use mc delta T. So we have two other things that we can use. Heat of fusion is the amount of heat required to melt 1 gram of solid or freeze 1 gram of liquid at the melting and freezing point. The heat of vaporization is the amount of heat required to boil 1 gram of liquid or condense 1 gram of gas at the boiling point. So what exactly do we do with this? Well, first of all, if we add heat, this is an endothermic process. You notice that as we increase in temperature, that's an increase in kinetic energy. So during the diagonal portions of this curve, kinetic energy is increasing. However, kinetic energy does not change when a phase change occurs. Therefore, kinetic energy remains constant, but we're still adding heat, which means potential energy increases as we add heat during a phase change. If we remove heat during a phase change, 334 joules for each gram if it's water to melt it, and 2,260 joules for each gram if we're going to boil it. And this is for water. Each substance has its own unique heat of fusion and vaporization. So we add heat of fusion to melt, we add heat of vaporization to boil. Now, going in the opposite direction is exothermic. For the diagonal portions, kinetic energy decreases as we lower the temperature, as we remove heat. But as the liquid condenses and then freezes, temperature remains constant. Therefore, it's not kinetic energy that's decreasing during these line segments, it's potential energy that's decreasing. So you have to remove heat of fusion in order to freeze, and you have to remove heat of vaporization to condense. Okay. So this heat of fusion business, you know these lines on the back window of your car? Well, I used to think when I was a kid that they were like an antenna for my radio, but they're not. When you push this button in the front dash of your car, it actually gives heat to wires that are embedded in the glass. Well, actually, it's not embedded, but it's laminated onto the glass. And that heat will help to evaporate away any fog that might have built up on the back window or melt ice that might have built up on the back window on a cold night. The heat you need to add or melt to melt a solid, or the heat you need to remove to freeze a liquid, is called heat of fusion. And this takes place at the freezing and melting point where the temperature remains constant. And these numbers are for water only. 334 joules can be added for each gram or removed from each gram to melt or freeze. And every substance will have its own unique heat of fusion. The heat of fusion is water. The heat of fusion of water is something really nice. Take away 334 joules per gram, and what you get is ice. You can find this, by the way, on New York State Reference Table T and B. Table B gives you the heat of fusion for water, and it also gives you the equations for how to calculate it. Q equals mass times heat of fusion. So if you want to find out how much heat it takes to melt or freeze, you just take the mass of water you're trying to melt or freeze and multiply it by the heat of fusion. And you'll see why this works with the units. So how many joules are required to completely melt 55.7 grams of water? Well, Q equals mass times heat of fusion. So we plug in the mass, 55.7 grams, times 334 joules per gram. The grams will cancel and leave you with joules. And of course, 3 sig figs, 3 sig figs. We have 3 sig figs in our final answer. How many joules must be removed from 143.2 grams of water at 0 degrees Celsius to completely freeze it? Well, we just take the mass and multiply it by the heat of fusion. And then grams will cancel and give us the number of joules. However, we must round it. 4 sig figs, 3 sig figs, so we need to round this to 3 sig figs. So the answer should be reading 47,800 joules if properly rounded. Heat of vaporization is the heat you either add to boil a liquid or remove to condense a gas. By the way, this is why you sweat. The process of sweating puts water on the surface of the skin, and the water evaporates. When the water evaporates, it will remove heat from the skin in order to do so, making you feel cooler. Now, different animals have different ways of cooling themselves down internally. We sweat. Dogs sweat also, but only through the pads of their paws. Other animals, like elephants, have large ears that the heat can be eliminated through, just like a radiator. But in humans, we get rid of excess heat through sweating, and the evaporation of that sweat absorbs the heat from our skin, making our skin cooler. Remember, endothermic processes result in a drop in temperature. This is the same reason why you feel cold after you've taken a shower, because the water on the surface of your skin is evaporating, and that evaporation removes heat from your skin. Okay, so again, this takes place at the boiling point. Now, for water, 2,260 joules must be added to boil or removed to condense. Now, this is much larger than the heat of fusion. The heat of fusion is only 334 joules. But remember, when you're melting, you're only weakening the attractive forces enough to break the crystal lattice and allow the liquid molecules to flow. To turn a liquid into a gas, you have to utterly destroy the attractive forces, and that takes a lot more energy. So again, table T and table B. Table B gives you the heat of vaporization as being 2,260 joules per gram. And Q equals the mass you're trying to boil or condense times that 2,260 joules per gram. So how many joules are required to completely boil 152.4 grams of water at 100 degrees Celsius? Well, all you have to do is take the equation, Q equals mass times heat of vaporization, plug in the mass, plug in the heat of vaporization, your mass will cancel, and give you your heat of vaporization. 4 sig figs, 3 sig figs, 3 sig figs. How many joules must be removed from 53.7 grams of water at 100 degrees Celsius? Now, by the way, why are they saying at 100 degrees Celsius? Because in order to use heat of vaporization, we have to be at the boiling point. So we're not actually going to use this 100 degrees Celsius for anything. It's just telling us we're at the boiling point. Go ahead and use heat of vaporization. So we take the formula and we plug in the numbers and we get the canceling out of the grams, which gives us our joules required to condense it. So it's a very simple process to calculate this. Now, the key ideas to remember are as follows. When you melt a solid, you have to add heat of fusion. Boiling a liquid requires adding heat of vaporization. So when you go up in phase, solid to liquid, liquid to gas, that's endothermic. Freezing a liquid requires you to remove heat of fusion. Condensing a gas requires removing heat of vaporization. So going down in phase from gas to liquid or liquid to solid That requires removing heat. That's exothermic. And that, ladies and gentlemen, is heat of phase change. Once again, I hope you've enjoyed it. Once again, I hope you have a wonderful day, and bye.